Hello, everyone. So I'll just show you, we have a bit of an audience with us.
Oh my gosh. Hello, how's it going, folks?
So just as a brief introduction, this is Bryan O'Sullivan. He is the current SVP of software at Zoox, who are an autonomous taxi company. He is the lead author of Real World Haskell. And I had some other marketing material. And yeah, and a big industry veteran, over 20 plus years experience in the software industry. So
Yeah.
Bryan, if you'd like to give yourself a more detailed introduction, that'd be great.
Yeah, absolutely. So first of all, thanks for inviting me to come talk to folks. So let's see. I've been in the industry for about 30 years actually. I started getting like summer jobs at the end of my first year of college in Dublin, and it's just kind of rolled on from there. So I came to California back in 1995. So what we time travelers refer to as the previous millennium. And I've been here ever since. So this is what, year 28 in California, and been in Silicon Valley and San Francisco pretty much that entire time.
Nice, lovely. So how this will work is this is a fireside chat. And to those unfamiliar, I'm going to ask Bryan leading questions, and then he will, divulge us with his vast knowledge of the world. So we'll just start off nice and easy. So just give us kind of a brief overview of kind of your career and what steps you think you took that led you to where you were now.
Sure. So I went to college at Trinity, so not too terribly far away from yourselves. And I decided kind of towards the end that I was interested in seeing what this whole Silicon Valley thing was like. I'd never actually been to the States before. And I got an interview with a job in a town called Sunnyvale, which is about 45 minutes south of San Francisco, at a company called Sun Microsystems, which was a big deal back at the time, doesn't exist anymore. And I was like a smelly undergraduate at the time. They made me an offer after talking to me on the payphone for like several hours from California, in the student flat that I was living in. And they flew me over to California, and that's where everything kicked off. And so since then, I've kind of bounced around between small companies and big companies. Sun at the time was about 35,000 people, so it was quite large. And it was kind of the dominant computer manufacturer in Unix workstations at the time, which is a category of computer that no longer exists because everybody uses Linux these days. And after that, I went on to a series of kind of startups, started a company of my own at one point, worked across a variety of different industries under the umbrella of software, and then spent about 11 years at Facebook, now known as Meta, and went on to leave there last year and ended up at Zoox. So I'd say I spent probably the first 20 years of my career in engineering, actually writing code, and then probably more like, with stints in management, but really the last 10 or 11 years has been pretty solidly management, running teams of various different sizes. So like the last team that I was responsible for at Meta was probably about 2,000 people. And I'm in somewhere a vaguely similar ballpark, without divulging specific numbers here at Zoox as well.
So now that you're more in management rather than engineering, when you're building teams, what do you think is the most important thing to look out for when, putting together a team and trying to get a product made and shipped?
Yeah, that's a great question. I mean, like you really have to think about it as a team sport, right? So in the same way that like, a sports team that's consisting entirely of a bunch of star players isn't necessarily a team because they don't know how to work together. You are at a significant disadvantage if you're building like an engineering team, if they are, all individually brilliant, but can't actually agree on what to do, because, modern problems are not problems that can be solved by just one person, no matter how smart they are, if they're large enough to be interesting and economically meaningful. So you really have to have like a combination of technical skill, but also people skills. And I just can't emphasize how important it is to be able to, get along with other people, learn from your mistakes, admit your mistakes, be able to kind of, just be sort of a good citizen of the crew that you're in, and, hold your own when you have to, but also be willing to compromise as well.
Brilliant. So could you give just a brief overview of Zoox and what you're doing there and kind of what you're overseeing within the company?
Yeah, sure. So Zoox, as you mentioned, is an autonomous taxi company, by which I mean we build like robotic vehicles that will be transporting people around in, urban areas. And I'm responsible for the software teams, right? So that's everything from the AI that actually drives the vehicles through to the mobile app that people will be using to hail rides, through to all the other software that handles the logistics of like sort of depot kind of things. If you think of like how you manage a fleet of buses or taxis or things like that, some of them are in service, some of them are not. You need to know where they are. You need to know where they are relative to your customers and so on. So all of that sort of stuff as well.
Cool. So I'm just going to ask you some more kind of general industry questions and love to hear your thoughts on them. So AI has shown its potential to be disruptive. What do you think like large language models will do in terms of software development, and how can people effectively approach using these large language models in their careers?
So the amazing thing about the developments that are going on in AI at the moment is that like everybody on this call is almost as much of an expert as I am. So like your own prognostications are about as valuable as mine, but it's super interesting what these models are capable of, right? So even today, right, we're already seeing cases where models like say GPT-3 are capable of these kinds of surprisingly unpredictable interactions with the physical world, right? People have hooked them up to robotics control systems and given them English language instructions such as, scan the contents of this shelf in a zigzag pattern. And it sort of kind of gets things right because it's able to actually format like instructions in a way that some API can consume. And it's sort of in the ballpark of plausible. It gets a bunch of stuff wrong because it's not designed for that. But the fact that it's actually capable of doing a reasonably decent job with no specific training is kind of amazing. So it's fascinating what large language models are capable of beyond just large language models in terms of like what you would expect on the CAN. How that's going to affect how we write code is, I mean, it's going to just become more and more interesting as time goes by, right? And I've been adjacent to this world for a while, right? The very, very early versions of this were pretty much like fancy autocomplete, right? You start typing in a piece of code, you hit tab, and you get some block of code that kind of roughly matches what you want, which is still sort of the state of the art, except now you can do things like, specify what procedure you would like to have written and something will get generated that vaguely makes sense. The limits on this are hard to comprehend. We're nowhere near exploring them just yet. The thing that is, of course, going to be difficult is all of these things are riddled with errors and hallucinations that are actually really, really difficult for humans to pick up. And so it's not like you can just take whatever the model emits and trust it to be correct, right? And it turns out that people are really, really poor proofreaders. So if a model produces some code that sort of looks syntactically correct and sort of does more or less what you expect, but happens to contain some critical mistake, the chances of you spotting that as a reader are not the best. So that's really where the risks come in all of these situations. And we can't just naively apply these things and expect them to work. It's going to require probably years of effort before we're able to just say, yes, of course it does exactly what we want all the time.
Brilliant. And aside from AI being kind of the real hot technology at the moment, what other technologies do you see on the rise currently? And what would you recommend for a budding student developer to explore or even just to check out?
Well, not surprisingly, I have opinions about how robotics might be very interesting and autonomous vehicles. Outside of that, I mean, it's actually, I'd say that the industry is in a bit of a lull in terms of like really interesting new things happening and has been for a while. So it's pretty clear that there's a lot to explore across the space of AI and applications of it, right? Even modern robotics is actually pretty heavily driven with AI and by AI, right? There's whole books and conferences devoted to what's called probabilistic robotics. That is robotics that are driven by these statistical models or AI models. So there's just a ton happening across that space. So even though these large language models get the top billing because they're sort of intrinsically approachable and exciting, and you can just talk to ChatGPT yourself, it's only the tip of the iceberg of what's actually possible. Now, the thing that I think is really challenging about that is these models are incredibly expensive to train and run. So the frontier that we really need to push as an industry is, how do we bring down the cost of training and running one of these models by, you know, several orders of magnitude, so that they become affordable and something that you can actually do as an individual or a small team rather than a Google, a Meta, or whoever. And then also, how do we, like, what's the next frontier in this kind of model development, so that the models themselves become more tractable and don't have to be trained for ages on incomprehensible quantities of data, because that's a significant roadblock to further progress as well, right? So the fact that all of this today is really only accessible to the very largest of industrial players is a significant issue. But if you look at the past 10 years of progress in AI, it's been, I don't know, you could almost imagine a dog sticking its head out the window on a highway with like its ears and fur flying back. That's kind of how rapid the pace has been. But there's also such a low signal to noise ratio, because there are so many people in the industry now and so much nonsense, that it's actually significantly, it's hard to find genuinely useful information and genuinely useful techniques that are being applied, because of the number of people who are just sort of, you know, chancing their arm to want to look for a better phrase. So you got to watch out for the snake oil salesman.
A good point. So what technology stack would you be using in Zoox, and how would you go about choosing a technology stack, both from the product end and also for the ease of development end? Now, I don't want any proprietary information either.
No, I'm not going to give you any proprietary information, don't worry.
That's good. That's good.
It's all really built from the ground up, right? Because the specifics that you need for any of these applications are so particular to the domain, and also to even characteristics of the vehicle, the sensors that you use, the compute that you're using, that it ends up being like incredibly like latched into like the whole stack that you're building. And so in our case, we have you know, a very strong team that does all of that kind of work, and they've put years of work into building, refining, replacing, and revising these sorts of models. So it's been a journey that has been exciting, but is also, you know, very much still in progress, right? So it's a combination of like research and development. Is it possible to do this? And also then, how do you scale it to work in industry and practice?
Oh, I'm going to briefly pivot the talk towards functional programming, because
Sure
I
thing.
understand I'm a huge nerd about it, and I think you are as well. So what was your first kind of point of contact with functional programming, and what really kind of stoked your interest?
Yeah, I came across it for the first time in college, actually. I was a bit of a chancer as a college student. I applied for an internship at a supercomputing research center in Switzerland, and it was their first time running the internship, so they didn't get enough applications. And so I was one of the applicants that was actually accepted into this job. I was a second-year undergraduate, so I barely knew how to program. And everybody else who got accepted were PhD students. So I was like at a massive disadvantage. So I packed this book into my bag that I had just bought because I liked the cover of it, and it was called Elements of Functional Languages. And there I was in Switzerland, working with this bunch of like very smart people with no idea what I was doing, and this book that I did not understand, but it was the only book that I had. And so I just ground my way through it for months, watching the storms roll through the mountains overhead at night. And eventually I sort of understood what was going on. And then the following year, I picked up another book, because the computer science library at Trinity is pretty amazing. And I emailed the author and I said, hey, is there any chance you'd give me a job for the summer? And he was like, oh yeah, fine. What I didn't realize at the time was that the author of the book, a guy named Simon Peyton-Jones, was actually the leading researcher in functional programming in the world at the time. And he was at Glasgow University, which was the leading center of research in functional programming at the time. So for whatever reason, he decided to take a chance on me, and I packed my bags and went off to Glasgow for a summer, and ended up doing a bunch of work in Haskell, and it just sort of stuck with me. So If there's a lesson to be learned from this, it's like, reading hard books can sometimes be fun, but also just taking chances on complete strangers is very much worth it too. And in this case, with Simon, I last spoke to him a few weeks ago, right? We've been in contact for 30 years, and this random book that I happened to bring with me to Switzerland literally changed the direction of my life because I'm stubborn. And it was the book that happened to be in my bag.
Brilliant. So kind of going into the more technical aspect, we see like, a functional programming is a different world to the like imperative style of programming. What techniques can people take from functional programming to add to their kind of general toolkit as a developer?
I think one of the more useful things that you can think of in normal day-to-day programming that you could take from functional programming is just this idea that your code should be as clean as possible in terms of what it does, right? So you're much better off having like little units of code that are easy to understand, don't produce any surprises behind the scenes, kind of do one thing wherever possible, and if you call that function over and over again, it's just going to do the same thing over and over again, rather than remember what you did last time and do something different that next time. The reason for this is it just makes your ability to reason about what your program is doing as you compose it up into larger and larger chunks much, much more straightforward. So that's one durable thing to do. A second durable thing that's incredibly valuable is there's a whole category of automated testing that people have kind of pioneered in the functional programming world called property-based testing. Now, you'd be familiar with, say, unit testing, which is kind of hand designing a little piece of code that tests another little piece of code. Property-based testing tries to step one level of abstraction up from that. And what it does is you're trying to think about properties that ought to be true about your code before and after it runs. And then you generate data as input to your code that tests whether that property is true. And you're writing a generator for the data, so it just generates different kinds of random data over and over again, tests your code with all that random data, and tells you a counterexample if it ever finds a case where the property ends up not being true. So compared to a unit test, it's a little bit similar, except you're operating at that higher level of abstraction, but you also get a lot more test coverage, of course, because instead of one hand-built test that tests exactly one aspect of your code, you're generating data probabilistically that will, generate test cases that you would never have come up with yourself. And so it's incredibly powerful. It's a little bit of a head melter to actually get yourself into that way of thinking, but it is very applicable to all kinds of areas. And if you were to look at, programming languages like Rust or whatever, they do have property-based testing libraries now. So it's starting to come a little bit more into the general consciousness, but it's not really nearly as widely applied as it could be. And I've found it to be immensely, immensely powerful in writing code that doesn't surprise me once I put it into production.
Speaking of Rust, Rust borrows a lot from functional languages with maps and filters and lambdas. But we've seen Java, for example, have like lambdas implemented in one version. Do you think there's a trend in popularity, a growing trend with functional programming? Do you think it's kind of growing in popularity nowadays, or?
I mean, it's been influential, but it's been influential sort of like that hipster band that you and your friends know of, but like your other friends have never heard of, and they're like, why do you listen to that? So it's like, I don't know how much further it's really going to go, right? Haskell has been just off stage in the shadows for 30 years, or longer than that, 35 or something. It has been influential, right? Rust very properly borrows a lot of really interesting ideas from it, because the original author of Rust, a guy named Graydon Hoare, was big into OCaml, which is another functional language, and was also personally heavily influenced by Haskell as well. So I'm totally fine with the influence being a thing rather than the actual direct use being a thing. Although I do think that the direct use of these languages is beneficial, because they put handcuffs on you that end up being really powerful aids to the imagination, because now you're having to do the same work but with handcuffs. And creativity is, of course, the thing that comes from those kinds of constraints.
So since you've probably had to build hundreds of teams of programmers, or at least teams of very large groups of programmers. What's the one thing that sets it apart? Is it solving dynamic programming questions, or is it something a bit different?
What are you talking about now? Are you talking about in terms of like building a team, or the people, like the traits of the people that you want, or what?
I'd say more the actual strength of the developers themselves when you hand them an editor and you give them a task.
I mean, it really varies depending on their level of experience, honestly, right? So like the big tech companies in Silicon Valley have a very similar kind of set of progression ladders in terms of what they expect people to be capable of. And so if you're a new graduate, right, it's typically expected that you have to be given these relatively small tasks because you're still, finding your feet as a developer. You're maybe not able to put together like a good plan for a larger project just yet. But by the time you're able to do that, that's when you get promoted to the next level. And then maybe you start taking on more responsibilities on larger projects. You're independently coming up with what those projects ought to be, and so on. So, so like a really well-functioning team has a variety of different levels of seniority, right? Because there are things that like, a very experienced person with 20 years under their belt is like, it's just not economically the right call to ask them to go and do some fairly small tasks when like a new graduate can bang that stuff out really fast using their powerful leak code skills, and they'll learn a ton from it as well. Whereas the person who has 20 years of experience is better put to use thinking about how to orchestrate all these other people, what the project architecture ought to look like, and so on and so forth. And it all just kind of comes with time. I do think, though, that one of the things that's been really interesting to observe as, somebody who grew up in Ireland, obviously, and was exposed to like technology as it's practiced in Europe versus in Silicon Valley, is it's common in Europe in particular for people to want to progress in their careers by going into management early. And part of that is because the structure of how corporations work in European countries is very often focused on progression through management. And for people working in tech, that's actually a really significant problem, because you end up with managers who've never really done an awful lot of significant programming projects, managing programmers who want to become managers at the very earliest possible opportunity. So you end up with this situation of the blind leading the blind, and these hierarchies of like increasingly incompetent people all trying to do stuff. And, it's not a miracle that in Silicon Valley, where it's much more of a parallel path where you can actually become like a VP level programmer, I think it's been more successful to have like those career paths be similar and paid similarly and have similar amounts of influence, rather than the old school model of you have to become a manager, then a director, then whatever, like where you're dealing with just people, but you actually don't understand what the code does anymore. The good thing is, I think in Ireland in particular, there's been so much influence from Silicon Valley companies setting up shop in Ireland, that a lot of the culture that I see of companies growing up in Ireland and startups happening in Ireland is they look much more like that Silicon Valley model than they do like the old school European model. And the companies end up just doing much more interesting and better work as a result. And that's really cool.
So I understand that you've had a brief stint with Linux kernel hacking. Do you think contributing to open source is big for, big institutional players as well as just normal civilians?
I mean, yeah, all of these companies depend on all kinds of open source software, and they produce all kinds of open source software, right? I was very briefly responsible for PyTorch, which is the kind of the dominant machine learning framework. I was responsible for it for about a nanosecond before I left Meta. And, PyTorch was something that individuals could possibly contribute to, but it was also economically super important to Meta and to a number of other companies around the world, and to research labs as well. So it is important. I think it's a good way to cut your teeth as a developer too, right? If you have the enthusiasm and the time and the luxury to be able to do that kind of stuff. It's really how I cut my teeth, and a big part of how I kind of grew in my career as well. And so a lot of the code that I wrote, all the code that I wrote in my spare time, all the books that I wrote in my spare time, I made them available in open source. And it was beneficial to me, and it kind of set me up to be a little bit of who I am today, which I'm very grateful for.
And speaking of books, when you were writing, for example, Real World Haskell, without even mentioning the text itself, what did you gain from writing it, and kind of what did you have to overcome to be able to put that to print and have a
Yeah.
well-edited text at the end?
So it was my first time actually trying to write a book where I was trying to teach other people how to do something, right? So it's not a perfect book by any stretch of the imagination. If I was going to redo it, I would make a number of changes. But it was like a really good education for me to spend time thinking about, like, what are the things that I know and how do I get those into the head of a complete stranger who I only have a vague mental model of, in a way that they're going to actually be able to absorb it, right? So that business of trying to deconstruct what's in your own head so that you can transfer it into somebody else's head is just amazingly powerful, because it's teaching yourself how to teach. And I enjoyed that, and I found it to be exhausting, but it was also really fun to do. In terms of like benefits, it ended up opening the door to me, like teaching computer science as a guest lecturer at Stanford for a couple of years. That was really fun. I ended up doing, like, I basically sort of backdoored myself into being a pretend academic for a little while, right? Like I would show up at conferences and give talks and stuff like this. I was on the program committee for conferences. I had this aspiration to go to graduate school and maybe get a PhD and become a professor or something like that. I'm honestly glad that I didn't. But as a result of writing this book, I got to cherry pick all of the fun parts, which is, writing some papers, going to conferences, having drinks with researchers, making friends with them, talking about research, reading papers. And I didn't get to do any of the crappy part, like having to spend years at the grind and so on. So like it was super fortunate in that way. Another thing that was absolutely, utterly bizarre that I did not foresee was it turned me into a nano celebrity in Silicon Valley in particular. I remember I was briefly single in my mid-30s. I had been married. I split up with my ex-wife and was single for a bit. And I went on a date with somebody at a restaurant in San Francisco. And it was a first date, right? We were sitting at a table in this neighborhood. And we're having a bit of dinner together. And this guy stands up from a table across the way and he walks over to us and he leans in for a moment and he says, "Excuse me, I'm sorry to interrupt you. But I'm a big fan of your work," he says to me. And I'm like, "Oh, thanks very much." And then he walks away again. I'm like, "What the hell?" And my date says, she looks at me and she says, "Did you pay him to do that?" So no monetary exchange was performed. This was just one of those weird things that I never foresaw would happen. Only in San Francisco can something like that happen, where you write a book about some obscure aspirational technology and random people accost you in the street and say nice things to you. So there you go.
Brilliant. And you mentioned that you started a company at one stage. So what was that like? What was the experience there? Was it completely outside what you've done before?
I mean, it reminded me in many ways of things that I have done before, right? So you'll remember me mentioning about 15 minutes ago that I'm a bit of a chancer. Well, this was also taking a bit of a chance, right? So I was unhappy in my job and decided to leave it. And some friends and I found a mutual friend who worked at a venture capital company who gave us some seed money and said, "Here, go do a thing." So we went and did the thing. And after about a year of work, we had built a proof of concept that was interesting. But my girlfriend, right? So remember, this is around the time that I was single. Girlfriend at the time walks out of the bathroom one day with one of those little white sticks with the two pink lines on it. And this was long before COVID had been invented. And so it meant something entirely different, which is that daddy needed to get a real job. And so she walks out, she's got this, and I'm like, okay, great. Well, this startup business is clearly not going to pay off. Like, I really don't want to be trying to fundraise and change a nappy at the same time. So it happened that a recruiter from Facebook called as we were trying to figure out what to do. And she said, "Hey, so, would you be interested in coming to work for us?" And being an Irishman, I naturally decided to stick my neck out and go, "You know what? I might be, but I also have this company, so you could buy the company." And instead of telling me where I could put myself, she was like, "Oh yeah, fine." And so we got acqui-hired by Facebook as a result of, this like random series of coincidences. And that's how I ended up there, and like learning a ton over the course of whatever it was, almost 11 years. So it was an interesting thing because like we were bought for not very much money because we were 3 people. We weren't really a company, right? We barely qualified for the corner of a coffee shop. And so I got transported into this, what felt like a big company. It was the biggest place I'd worked in years. It was 3,000 people at the time. And I knew nobody, oddly enough, even though I'd worked in Silicon Valley for years. I think I had one friend who worked at Facebook at the time. So I had to kind of establish myself. And Google bought the IP. So it was a weird thing where like Facebook got the humans, Google got the intellectual property, and the investors got their money back, right? Which if you're a venture capitalist is almost meaningless, right? Because you put in some money and you get the same money back out again when you want to be getting 1,000 times the same money. But at least they didn't, lose their pocket change behind the couch. And that's just, another one of those like random, you never know where it's going to lead kinds of stories.
Brilliant. So what would you say would be the companies you learn most from outside of college and everything, where you're kind of really put to work and had to learn a lot at once? And
I mean, without a doubt, it was Facebook, right? Because to kind of continue that story, I had done some management, but the previous biggest team that I had ever run was about 24 people in size, so it was not that big. And I got dropped into Facebook as sort of a mid-level engineer, just back to writing code again. And after about a year, I realized that the work that I was doing needed a team around me. So I like got some people to work with me. And then I was like, oh, we need a manager. And so I went back into management. And then that just snowballed. I began to run a bigger team. I had some severe disasters along the way, right? Like I messed up some significant management assignments that ended up with more or less blood on the floors. I nearly quit over some of those, but I stuck it. And by the time I left, as I said, I was running a team of about 2,000 people. So you can imagine at that pace, right, over 10 years, going from one person to 2,000, I had to every 18 months or so relearn how to do my job almost from scratch, because the characteristics of being one person, managing a team of 15, managing a team of 30, managing a team of 60, it changes over and over and over again in terms of the problems you're solving, the people that you work with, the skill levels that you need in order to get your job done. So I'd say for about 50% of the time that I was at Facebook, I was incompetent at my job because it kept changing, and I had to keep learning and adjusting in order to get that done. And it was a tremendous, experience in every way. It definitely caused me to have a lot of sleepless nights along the way because of the incompetence, but yeah, I wouldn't change it in any way.
was there one kind of common thing, that one kind of common trait of your own skill set that always showed up in those big transitions where your team size is doubling or tripling or something?
Yeah, I mean, there's probably two actually. One is I really, really love learning things, right? I'm one of those poor Egypts who actually reads Wikipedia for pleasure, just random Wikipedia pages, and then I'll start clicking on the links and I'll read about all the other things. So if you want me to tell you about Lama Berserker syndrome, I will, and it's a real thing. But the other thing that was incredibly important to me as well was, I grew up this absolutely nerdy only child in a small town. I come from Waterford, so 40,000 people or whatever down in the southeast. And I had zero social skills, no riz if you're a TikTok watcher. And I had no idea how to interact with or relate to my fellow human beings, but I was so intensely lonely as a result of a life of computers and books that I just stubbornly taught myself all of these skills. And that combination of learning and devotion to people was the twin pair of things that were incredibly powerful for me, because I could pick things up really quickly. And over time, I actually learned to be like a pretty good people person. A lot of the time I describe my job now in management as being like 50% overpaid babysitter and 50% underqualified therapist. And it's really kind of true, right? That's I think an interesting combination for somebody who, I still have to do some technical stuff sometimes, but most of what I'm doing is I'm understanding people's motivations, fears, goals, and then trying to match those as best I can to what the organization needs to be able to do in order to move forwards. So you can teach yourself an awful lot of things, such as how to go from a completely clueless loser to a reasonably good human being with enough application of elbow grease, it turns out.
So what is that syndrome again? Maybe you could explain it. You've
Llama
piqued my
berserker
interest
syndrome.
now.
Okay, this is brilliant. And it probably applies to programmers, actually. So llamas are herd creatures, right? And they're quite bloody big. And they're related to camels, even though they grew up on, like, opposite continents. And it turns out that if you raise a llama solo, only surrounded by humans, because it's a herd animal, it understands the humans around it to be part of the herd. And as it reaches adolescence, it wants to establish its place in the herd. It wants to establish its, dominance relationship to the other herd animals. But llamas are bigger than humans, and they're nasty as fuck, for want of a better description. And so what they'll do is they'll start attacking people, the people that love them, that raised them, because they want to figure out where they belong in the herd. And all they're doing is just following their natural behavior. But it only happens with humans, right? So if you raise a llama with other llamas and there are humans around, the llama is aware of the distinction between humans and llamas, and it's going to go, it's going to go like 10 rounds with the fellow llamas, and they'll establish their hierarchy, and then it just treats the humans like regular, other kinds of mammals. But if it believes that humans are llamas, then it's bad news for the humans. They can actually be killed or maimed by the llamas. And who wants to have, like on their gravestone, killed by a teenage llama?
Do you program for fun often now, or are you just taking it easy programming wise? And if so, what would be your favorite language to write in?
I do a bit of programming for fun still. I write a fair bit of Python to do like random bits and pieces, mainly because it's just, there's so much kitchen sink stuff available that allows you to do kind of whatever you want. I've also been doing, like, I spent a chunk of last summer teaching myself how to use the Godot game engine to basically write, games. And that was also really fun because I had been an aspirational game author who never actually did any game writing for many, many years. And coming across this like open source engine that ends up being like really powerful and easy to use and allows you to put together like interesting stuff very, very quickly and cheaply was just tremendously exciting and fun. So those are kind of my main outlets. I can still write Haskell and I can still read it, but I don't have the energy, to be perfectly honest, to put into like serious programming. So it's mostly little Mickey Mouse projects these days.
And do you think you feel better suited being an engineer or a manager? What would you feel is more fun?
Yeah. I mean, I was a great engineer, but I wasn't a great engineer because I was like intrinsically talented. I was a great engineer because I'm very, very stubborn, and I developed the skills to become to go from a crappy engineer to a great engineer over time. But in my case, I got bored with it. Like at some point in my career, I felt like all the problems that I was solving were the same, and the frustrations that I was experiencing were the same. And so I made an explicit choice to just step away from that and go into management in the full knowledge that I wasn't necessarily going to be any good at it, but I needed a change. I would say these days I'm a more valuable manager than I am a programmer. But it still has its frustrations. I still make mistakes, only now they cause other people problems instead of a computer problems. And I think it really, you learn a lot of humility as a manager when you're trying to, do the best for other people, but you also have to recognize that your best is going to fall short on a fairly regular basis. So it's a very good way to keep you from getting too big for your boots.
Awesome. So since we're all students here, do you see any technologies growing in the future and that could give you a better kind of skill set as a developer? Like, for example, Kubernetes. That's what I'm learning a lot about now.
Yeah. I mean, Kubernetes feels like it's sort of inevitable, but it's also gross and nasty, and like I'm very glad that I can hire people to care about Kubernetes for me and pay them instead of me having to be elbows deep in its guts. But it's going to be around until pretty much the end of time, just like every other technology that becomes indispensable. If you look at like the AI side of things, which I think is still worth paying a vast amount of attention to. Obviously, PyTorch is a big deal, but PyTorch is only going to be dominant for, I think, a few years because there's all kinds of interesting things coming up that are still in the works, right? So, for example, the folks who built I'm not sure it's exactly the same people, but there's another machine learning framework called TensorFlow, and there's a neighboring library that's been built at Google called JAX that it's a much lower level library than TensorFlow or PyTorch, but it has a number of interesting capabilities around doing differentiable programming and reverse mode automatic differentiation of your code, which ends up being really important for doing efficient machine learning. And so that world of like probabilistic programming and, you know, really being able to like think fluidly around floating point numbers, statistics, like, you know, optimization and so on, that is, it's going to be a big deal for many, many years to come. But it's also, don't get me wrong, quite hard. Now, the ways that these technologies are being built, the high level stuff is becoming more and more accessible to regular folks like me. But the low level stuff is super interesting in terms of just how much need there is for it to get better, how much interesting research there is into making it get better, and how much potential there is if it does get better, right? We could, as a society, really benefit from it being 10,000 times better than it is today, but the path there is extremely murky and littered with papers that look convincing but are not true.
So before we open it up to Q&A, if you were able to, you know, get a flux capacitor and go back in time,
Yeah.
and you're able to say to student Bryan, you know, one piece of advice to keep you, to turn you on the right path, what would it be?
I think I was very, very lucky. I got on the right path entirely by accident. I was an absolutely shite undergraduate student. I maintained a 2.2 average, aka a C grade, throughout my college career. Not because I was stupid or dumb or anything like that. Like I you know, very judiciously spent my time split between the computer lab, the library, reading these books, and the pub. And you know, all three were important, but I put all of my time not into what the lecturers thought I ought to be taught, but the things that I thought were genuinely interesting. And that was where I learned about Linux. That was where I learned about, you know, systems programming, all these things that got me my start in my career, and functional programming, which ended up, as I said, kind of changing my life. So I got extraordinarily lucky in this random series of like just things that interested me and pursuing those because I was stubborn and didn't care what the lecturers thought I ought to be taught. I don't think that's necessarily a life lesson that anybody else ought to apply. I just happened to get lucky with that. But, you know, like if there's a point to that, it's that like you shouldn't stress too much about what your career ought to be or what classes you ought to take or things like that. Just like relax and enjoy it and do the things that you like and stay away from the things that you hate unless they're necessary. And maybe things will be fine. End of sermon.